Hello and welcome to Nikolay's genetics lessons, and today I'm going to talk about difference between coefficient of relatedness and coefficient of inbreeding. How these two terms are different, and imagine that we have such situation as in this pedigree, this line diagram, which is easier to use than normal pedigree that we usually see in the textbooks. So we see here one parent. Second parent is not shown here for simplicity, but we have to understand that one parent cannot produce children, so have to be two parents. So, but this diagram would be enough for us to find coefficient of relatedness between individual Z and X. So we see parental generation here. This would be children. This would be grandchildren, and this is going to be grandchildren. And now let's find what is the coefficient of relatedness. As you know, we get 50% of our genes from our mother side and 50% from our father side. Those here only one parent is shown, we can say that this parent contributed 50% of the genes of the individual A. So let's put 50% here. And of course contributed 50% genes of the individual B, individual L, and individual K. So each child got here 50% of the genes from the parent Z. And now what is interesting that, for example, individual S, whose parents A and B, and who is going to be siblings, would have the same 50% genetic makeup, just like his parents, and not 25%, what we normally see for grandchildren. So every individual has two parents and got 50% from one parent and 50% from the second parent. And each grandchild has four grandparents, two from his mother side and two from his father side. But in this case, we see that this individual S has only two grandparents, grandparent Z and another grandparent that is not shown here, just like his parents. So we see here inbreeding. Once again, if individual A got 50% of the genetic makeup from parent Z, we can say that parent A would also pass 50% of this 50% to the child S. So would give 25% of what he got from its parent Z. So 25%. And individual B also would give 50% of 50%. So also would give 25% of its genetic makeup that he got from parent Z. This gives us coefficient of relatedness of the parent S. Let's say that this is going to be female, as 25% plus 25 would be 50%. So individual S would be related to its grandparent by 50%, just like children of this individual. And the same picture we see here. Individual L would pass 25%, would pass 50% of what this individual got from its parent. So 50% of 50% would be 25%. And individual K also would pass 50% what he got from parent Z to its progeny. So 50% of 50% would be 25%. And we can say that individual T, this is going to be a male, because as you see, individual S and D also mate and produce individual X. so have to be of the different sex. So this individual also would be related to its grandparent by 50%. So 50% of the genes this individual will receive from individual Z, because individual D, those being a grandchild, has only 2 grandparents, not 4 grandparents. And if both parents has 50% of the genetic makeup that they got from the ancestor Z, they have once again 50% chances to pass this genetic makeup to individual X, the child. So 50% of 50 would be 25%, and individual D also going to pass half of what he got here, so it's going to pass 50% of 50%, or 25%, to individual X. So individual X, let this also be female, would have 25% plus 25%, would have 50% genes inherited from the ancestor Z. So what is interesting here is that say this is going to be children of the individual Z, and these children would have 50% genetic makeup of one of the parents, parent Z, and because we have here inbreeding, grandchildren also would have 50% of the coefficient of relatedness to grandparent Z, and grandchild also would have 50% coefficient of relatedness to grandparent Z. What is interesting that grandchild would have the same genetic makeup as a child of individual Z. So individual Z can also consider this grandchild as its own child from a genetic point of view. And now let's talk about coefficient of inbreeding. So here is the same pedigree. I just use another picture because here is a lot of numbers that would interfere with our new calculations of the coefficient of inbreeding. Now let's consider that individual Z has 2 alleles, allele A1 and allele A2. Coefficient of inbreeding would be probability that individual X would inherit 2 alleles, same alleles, so would be homozygous by descent, and would inherit allele A1 through his mother side, and the same allele would inherit through father side, and would be genotype A1 and A1. So this is going to be homozygous genotype. So let's find probability for individual X to be homozygous for 2 same alleles. And probability that individual A would inherit allele A1 would be 1/2, whether this individual may inherit A1 or A2. So 50% probability that this individual would inherit A1. And if this individual would have A1 allele, what is the probability that this individual would pass to its progeny S? Exactly same allele. Once again, probability would be 50% or 1/2, and probability that individual X would get this A1 allele from parent S from its mother would be also 1/2. So probability that individual X would be would have one allele A1 inherited from the mother side would equal to 1/2 multiplied by 1/2 and multiplied by 1/2. But we are looking for individual X to be homozygous, so to have two A1 alleles. That means that second allele, A1 allele, this individual have to get from his father side. And what is the probability? And probability would be, say, this individual D may inherit from parent K, so parent K may have 50% probability of getting this allele, 50% probability of passing to individual D, and individual D would also have 50% passing this allele to individual X, and now individual X would have two A1 alleles. So probability of such an event also have to be included that individual X would inherit this allele through the father side. And such probability would be 1/64. And this is not the only way how individual X can get A1 allele from mother side and A1 allele from the father side. Another variant would be from the mother side the pathway would be the same, but from the father side this time the pathway would be different from through the individual L. So this is going to be second variant of inheritance, so we have to add this probability. So now we have to use a sum rule to add these probabilities. And another variant would be through individual B, S, and back to X, and Z to L, through D to X, so plus 1/64, and one more time the same pathway through the mother side, and a new pathway through the individual K, D, and to X. So as you see, 4 variants are possible how individual X can be homozygous for the A1 allele. So 1/64 plus 1/64 plus 1/64 plus 1/64 would equal to 4/64, or this is the same as 1/16. So this is going to be probability for individual to be homozygous for A1 allele, but as you see, this individual also can be homozygous for A2 allele, so may have genotype A2A2, and also would be homozygous by descent due to inbreeding, and basically all the calculations are going to be the same, and probability of him being A2A2 homozygous genotype also would equal to 1/16. So total probability of him being homozygous, whether for allele A1 or allele A2, would be combined probability of this individual to be homozygous for A1 and A2 alleles. So A1 genotype or A2 genotype probability would equal 1/16 plus 1/16. So 1/16 plus 1/16. And probability of this individual X to be homozygous for the same allele inherited from the common ancestor would be 1/8. So this is going to be an inbreeding coefficient. If you need an answer in percentage form, you have to divide 1 by 8. You're going to get 0.125 and multiply by 100, and the answer would be 12.5% is inbreeding coefficient of this individual. Once again, inbreeding coefficient means that about 12.5 loci of this individual would be homozygous by descent. We just took one locus, but one locus means one gene. Normally, organism has thousands of genes, and once again, this number gives us information that about 12.5% of all genes would be homozygous by descent. So this is our coefficient of inbreeding, and coefficient of relatedness, once again, between individual Z and X would be 50%. I hope my explanation were clear enough. Now you understand the difference between coefficient of relatedness and coefficient of inbreeding. And this is all for today. Thank you for your attention. Please subscribe for my new videos that I post almost every day. Thumbs up if you like this video. Please write your comments, questions if you have any. Share this video with your classmates, and see you in the next video. Goodbye.